Okay guys, welcome back. Some of that stuff on page 3, the determinant of 3 by 3 matrices, apparently it was removed from the homework for this semester because we lost that week. So from the last video, you really only have to pay attention to the stuff that happened at the beginning. I didn't know that until I went through the homework and checked it just now. Furthermore, the rest of the stuff from the 5.3 notes is gone as well, except for the stuff at the top of page 6, which is Cramers Rule for systems of equations. So we'll talk about how this works. If you've got 5x plus 7y equals negative 1, and 6x plus 8y equals 1, you're trying to find the solution. I know most of you would just decide to find the solution in a 2 by 2 way, but there's a way to use matrices. First off, we have what we call the determinant matrix. That's taking all of the x's and y coefficients and putting them in a matrix. Then we've got what is called the determinant X matrix. Basically, it's the determinant matrix with the answers replacing the X coefficients. So all of the Y's stay the same, but we're replacing the X's with the negative 1 and 1, the answers. And the determinant solution for Y is the same thing. Instead of replacing X, though, we're replacing the Y terms with the answers. And then from here, you're going to find the determinant of the matrix. So in a 2 by 2, it's top left to bottom right. So that's 40 minus 7 times 6, 42, which is negative 2. And do the same thing for all the matrices. Negative 1 times 8 is negative 8, minus 1 times 7, which is 7. Negative 8 minus 7 is negative 15. The determinant matrix with y replaced, 5 times 1 is 5, minus negative 1 times 6 is negative 6, so 5 plus 6 is 11. Now, the rule is x is equal to the determinant with x replaced divided by the original. That'd be negative 15 divided by negative 2, which is 15 halves. Y is the determinant with y divided by the original. So that's 11 divided by negative 2, which is a negative 11 halves. So your solution to this system of equations is 15 halves, negative 11 halves. This is the same thing you should have gotten if you were trying to use either elimination or substitution. It's just a different way of doing it. Now I want to do one more of these with just a 2 by 2. I'm just going to make it up on the fly, so it's not going to be what's on your notes, but we're just going to go with it. Let's go with 5x minus 3y equals 7, and then 2x plus 5y equals 12. I don't know how this will go, but we'll see. We'll make it work. Okay, so what's my original determinant matrix? 5, 2, negative 3, and 5. My determinant matrix with x replaced, so I'm replacing the x numbers with the answers, so 7, 12, negative 3, 5. And do the same thing with y. So 5 and 2 for x stay the same, but I'm replacing y with 7 and 12. And now we're going to find the determinant. So 5 times 5, 25, minus negative 3 times 2, which is negative 6, so it's 31. The determinant for matrix X replacement, that would be 7 times 5 is 35. Minus 12 times 3 is 36, but it's a negative 36. That's 35 plus 36, which is 71. And for y, 5 times 12 is 60. Minus 7 times 2 is 14. It is 56. So what are my answers for x? It's the x value 1 divided by the original, so 71 over 31. For y, it's 56 over 31, and 31 is prime, so it's not going to reduce, so your answer is just 71 31sts 56/31. This is usually why we don't create problems on the fly, but I just wanted you to see an extra example just in case. This is another way to solve systems of equations. And you notice there's only 7 homework problems on 5.3 now, so it shouldn't be too bad to do. They're all 2x2 determinants or 2x2 systems using determinants. So have a nice weekend.